Dear all, good afternoon. Myself s.abirami, working as an assistant professor in the Department of ECE, s.r.m. Engineering College. So in today's lecture, we're going to discuss about the subject electric circuit analysis. Electric circuit analysis is the study of how electrical quantities behave in the electrical network. That is, the electrical quantities means voltage, current, and power. How these three quantities behaves in the electrical network. So we have to analyze these three electrical parameters so that we can determine the amount of current flowing in the circuit, amount of voltages flowing in the circuit, and the power distribution in the circuit can be calculated. So to analyze the electrical circuit, we have some basic circuit laws, that is Ohm's law, Kirchhoff's current law, Kirchhoff's voltage law, superposition theorem, Thevenin's theorem, Norton's theorem, and maximum power transfer theorem and reciprocity theorem. So these are the basic circuit laws to measure the electrical quantities such as current, voltage, resistance, and power. So current, we all know that what is current. That current means the flow of electric charge. So the unit of the current is ampere, and the voltage means the potential difference. So potential difference calculated, that is called as your voltage. Then resistance means opposition to the current. Opposition to the thing is called as your resistance. The unit of the resistance is ohms. Power means the rate of energy consumption. P is equal to V into I in solo. So that is called as your power. So these four main electrical quantities can be measured with the help of these laws. So we'll see one by one. First one is Ohm's law. So Ohm's law states that the current flowing through a conductor is directly proportional to the voltage across it, where the temperature and other physical conditions remains constant. So the expression, mathematical expression for Ohm's law is V is equal to I into R. So this Ohm's law is invented by George Simon Ohm. So where V is equal to voltage, I is equal to current, and R is equal to resistance. So if we wish to calculate the current in the circuit, then the expression can be reframed as I is equal to V by R. If you want to calculate the resistance across the circuit, R is equal to V by I can be used. So V is equal to IR is the very basic mathematical expression used in the circuit analysis. So we can also have the better clarity with the example of water tap analogy for this Ohm's law. So for example, consider your so we have to measure the electrical quantity, voltage, current, and resistance. So relate these three things with the water system. So your voltage can be related with water pressure in the pipe. Your current can be related with flow of the water from the water tap, and your resistance can be related with tap opening and closure. So hope you will understand with this. So when your water pressure increases, so as I already said, water pressure is related with voltage. So when your water pressure increases, if it is a higher voltage, then there will be more current flow. Then there will be more current flow, that is higher current. When it has the more current flow, when your pipe is wider. When your pipe is wider means your resistance will be less at the time. Your resistance will be less at the time. That is, with a high pressure, high voltage, with wider tap opening is wider, less resistance, which is equal to more current flow. Then we can conclude as current and voltages directly proportional, and this thing is inversely proportional to the resistance. Your voltage and current is directly proportional, and which is inversely proportional to the resistance. Your current is inversely proportional to the resistance. Voltage is directly proportional to the current and resistance, and your current is directly proportional to voltage and indirectly proportional to the resistance. I is equal to V by R. Kirchhoff's law. Kirchhoff's laws are the two fundamental rules for analyzing the electrical circuits. One is Kirchhoff's current law, that is your junction rule. Another one is Kirchhoff's voltage law, that is your loop rule. So here it says the conservation of energy means that is your KVL. Conservation of charge means that is your KCL. So both KCL and KVL was developed by Gustav Kirchhoff. These two laws are very essential to solve the complex circuit problems. So by applying the principles of charge and energy conservation. Kirchhoff's current law. So KCL state that the algebraic sum of the current entering the node is equal to the algebraic sum of the current leaving from the node. That is, the algebraic sum of the currents in the node will be equal to 0. For example, here consider, so this is the node, so where we have 5 currents I1, I2, I3, I4 and I5. The currents I1, I2, I3 are the incoming currents to the circuit, whereas your I4 and I5 are the current leaving from the circuit. So the algebraic sum of I1 plus I2 plus I3 must be equal to the algebraic sum of I4 plus I5. So the current entering into the node must be equal to the current leaving from the node, says your Kirchhoff's current law. Next one is Kirchhoff's voltage law. It states that total voltage around any closed loop in the circuit must be equal to the sum of voltage drop. That is, sum of voltage drop is equal to sum of voltage rise, says your KCL. So here this V is your voltage. V1 must be equal to the voltages induced in the circuit V1 plus V2 plus V3. That is your KVL. Next one is your superposition theorem. So where the superposition theorem says that in any linear circuit with multiple independent sources. So the source is this B1 and B2 are independent, not dependent to each other. It is independent. So the total current or voltage at any point of the circuit must be equal to same when the sources are acting alone. So that's what they said as total current or voltage at any point is the algebraic sum of the individual effects from each source acting alone where the other is turned off. So for example, here this should be shorted, this should be removed or shorted. Okay, so at the time your source B1 alone acting to 20 volt. So now we can calculate the current over here I. For example, this I is your 10 amps. So next we have to shorten this source, this individual source alone acting alone where others is turned off. So at that time B2 your current will be I should be is equal to 10 amps, then your superposition theorem satisfies. So this is about your superposition theorem. Next one is your maximum power transfer theorem. Maximum power transfer theorem says that when your load resistance RL and the Thevenin resistance or Thevenin, that is your load resistance RL must be equal to the Thevenin resistance or TH. At that time, the maximum power can be delivered from this source to the load. At that time, the maximum power can be delivered from the source to the load. So this says about your maximum power transfer theorem. Next we will see one example problem related to Ohm's law. So consider the circuit having three resistance 6 ohm, 9 ohm and 15 ohm with the voltage of 18 volts. So by Ohm's law, I is equal to V by R. So I is equal to V by R means your V is 18 volts here. So for each and every resistance we have to calculate the current across that. So I6 equal to 18 by 6, that is V is 18, resistance is 6, so current obtained is 3 amps. Similarly for I9, voltage is 18, so resistance is 9 ohm and your current obtained is 2 amps. Similarly for 15 ohm, it is I15, 18 by 15, voltage by resistance, current obtained is 1.2 amps. So the total current, supply current equal to source current, the total current in the circuit is I6 plus I9 plus I15, 3 plus 2 plus 1.2 is 6.2 amps. Now we have to simplify the resistance value, because we know the total current across the circuit across these three resistance. So the current is 6.2 amps. What is the resistance value here? So total resistance R is equal to V by I. We know the voltage, total voltage across the circuit 18 volts, and your total current is 6.2 amps. The resistance is 2.9 ohm. So this three resistance now can be simplified as one single resistance, 2.9 ohm. This is your 2.9 ohm. So this is how the circuit can be simplified with the help of all these theorems. So we have discussed only the example for only one law, Ohm's law. Similarly, we can simplify the circuits with the help of Kirchhoff's current law, voltage law, maximum power transfer theorem, superposition theorem, Thevenin's theorem, Norton's theorem, reciprocity theorem. Right? Thank you.